Hi everyone, our project is about finding moment for solid. We are from Group 12 from Section 4.
Civil engineering is a profession that applies the principle of physics and mathematics to design and develop structure and method to use material and natural force for the benefit of mankind. Civil engineering courses apply mathematical principles and skills to practical problems. Courses such as structural analysis examine structures such as trusses, beam and frame, as well as concepts such as virtual work, energy, engineering and influence line. In addition, when defining various properties such as area, volume, center of gravity, moment of inertia, radius of rotation, slenderness factor, and so on, mathematics plays an important role in various cross-sections such as rectangle, triangle, circle, and composite cross-section important role. By using differential equation, mathematics helps to imagine problem situations in all disciplines and try to solve them. First, double integral. A given integral can be extended to a function of more than one variable. Basically, the distance is defined by horizontal and vertical strip that give the same answer. For example, consider the function of two variables z equal to f(x,y), where r is the integration area in the xy plane. If the definite integral a to b fx dx, a function with variable fx more than 0 or equal to 0 is the area from x equal to a to x equal to b under the curve fx. Then the double integral is equal to the volume under the surface z equal to fxy and above the xy plane in the area integral r. Triple integral. Instead of a region in the xy plane, we consider a solid in the xyz space. We are going to divide the region into rectangle, cut the solid into rectangular solid, and instead of multiplying the value of the function by the area of the rectangle, we are going to multiply the value of the function by the volume of the rectangular solid. Know the Cartesian coordinate, the cylindrical coordinate, and spherical coordinate. We can outline the triple integral because the restriction of the sum of the made from the feature instance, the extent of the rectangular solid instead of the double integral being equal to the double iterated integral. The triple integral is equal to the triple integral iterated integral.
Theory. In calculus, multiple integrals are defined as the integral of a function of more than one variable. Since the integral of the variable function on the interval give the area, the double integral of the function of the two variables calculated on the area give the volume. Function of three variables are triple integral and so on. Similar to simple integration, this type of construction can be used to calculate the net change in the function caused by the change in the input value. To understand triple integration, it is very important to understand double integration, three-dimensional coordinate geometry, and polar cylindrical coordinate. Triple integration, and based on this topic, it cannot be solved without this prior knowledge. Since volume is a function of t, it will change over time. Therefore, the result is integrated over t and a different volume is added during a certain period of time. Triple integral can also be used to represent volume, just as double integral can be used in the triple integral. Triple integral f(x,y,z) dz dy dx. If x, y, z equal to 1, then this triple integral is the same as double integral z xy dy dx, which is simply the volume under the surface represented by z xy. First, triple integral in rectangular coordinate. The volume of a closed bounded region D in space is V equal to triple dV Second, triple integral in cylindrical and spherical coordinate. Equation relating rectangular x, y, z and cylindrical r, theta, z coordinate. X equal to r cos theta, y equal to r sin theta, z equal to z, r cube equal to x cube plus y cube, tangent theta equal to y over x. Spherical coordinate represent a point in space by order triple P phi theta, in which P is the distance from P to the region. Phi is the angle OP make with the positive z-axis 0 until pi, and theta is the angle from cylindrical coordinate 0 until 2 pi.
Hello, my name is Shifani Mamati Hasni and I will be explaining about the question and solution. So for the question, it is, suppose that Q is a solid region bounded by x plus 2y plus 3z equals to 6 and the coordinate planes and has density rho xyz equals to x squared yz. Find the total mass and the moments of xy plane, the xz plane and the yz plane. Solution. So the region Q is a tetrahedron meeting that exists at the point 600, 030 and 002. So the figures show the coordinate on the xyz plane, and x plus 2y plus 3z equals to 6 is the solid region bounded by the equation. Okay, to find the limit of integration, let z equal to 0 in the slanted plane. Z equals to 1 over 3 times 6 divide subtract x and minus 2y. Then x and y, find the projection of Q into xy plane, which is bound by the axis and the line x plus 2y equals to 6. Hence, the mass is, so the formula for mass is density times volume. So mass equals to m. Triple integral Q rho xyz times dv equals to, so there's three integrals, right? Triple integrals. So each integrals represent dx, y and z. So the first integral is upper integrals equals to x6, and down integrals is x equals to 0. The second integrals is y, upper integrals y equals to 1 over 2 times 6 minus x, and the lower integrals equals to y equals 0. And the last integral is upper integral z equals to 1 over 3 times 6 minus x minus 2y, and the lower integral is z equals to 0. X squared yz dz dy dx, and equals to 108 over 35, and it will equals to 3.086. So 3.086 is the total mass of the solid. Next is to find the moment of the planes. To find the moments of the xy plane, the xz plane and the yz plane using the formula, about yz plane, use the m yz equals to triple integrals x rho x yz dv. For the xy plane, use the triple integrals y rho xyz times dv. And lastly, the yx plane, use the z rho xyz times dv. Using the above formula, we can find the moment about the planes. So using each of the formula, key in all the information that we got, and we got the first plane, which is the xy plane, equals to the triple integrals that we key in, the x, y and z value, equals to 54 over 35 equals to 1.543. For the xz plane, we got the 81 over 35 equals to 2.314, and lastly the yz plane equals to 243 over 35 equals to 6.9 over 6.943. Therefore, the moments of the planes xy planes equals to 1.543, xz plane equals to 2.314, and yz plane equals to 6.943.
We're going to find the moment about the planes by using mapper, calculator, device softwares. So look right here. We need to find mxy, and then we insert the 3 per integral at here, and then inside the the function at here, and then after we insert all the function and the limits, and we got the answer is 54 per 35, which is the same as the manual calculations. Next, after we find mxy, we need to find for mxz. Same procedures. We need to put the limit as is stated and the functions. So here we just need to change the function at here. X power of 2 y power of 2, and then z, and then close the brackets. Then after that we press enter, and then we get the answer, which is 81 per 35 in decimal form 2.314, which is this is the equal to the manual calculations for mxz. Find the moment about the planes, which is myz. Same procedures, just need to change the functions. So the functions stated here, which is x power of 3, and then y, and then z, and then close the brackets, and done. And then we got the result 243 per 35, and as decimal form is 6.9428, which is this also same with the manual calculation. For the overall of calculation between manual and by using software, the answer that we got is the same, and there is no problem or issues on finding the answer by using manual or software. Thank you.
As the conclusion, the derivation of the formula used to find the mass and the moment of the solid can make comparison with the computation of the software that uses a more accurate and simple mathematical calculation application. Triple integral are encountered in the context of density, where a density is defined as the amount of physical quantity per unit volume of a geometric solid. Such in the construction, like the single integral, are very helpful for the computing the net change in the function as a consequence of the change in its input values.